Hi, today I just felt like showing you a recorded version of my follow-up of the ESRI training. So this is JS for climate action, esri.com/training/MOOC. Okay, so this is section 5, exercise 1, create a heat risk index. So let me just record how I follow it up. Let's see my follow-up was okay. Yeah, introduction, this. You can read it, pause the video and read it, no problem. This, okay, and you're seeing the formula here, and look at it here. All right, you can pause the video, read that, no problem. Yes, here is the scenario. Okay, you can pause the video and read that. All right, estimated time 120 minutes, no problem. Now step 1, let's see the step 1. Look at this, you can read it. It said start ArcGIS Pro, sign in with it. Okay, they actually give you username and password for the exercise. Okay, save in the ESRI folder, no problem. This. Okay, so on the ribbon, this. Okay, so let me quickly just address this. Now in ArcGIS Pro, I've already signed in with the username and password they assigned to me. Then the add data button they were referring to is this. I could click on that, but here is the catalog pin. It's usually here. I can come to the portal, and then this is the same living atlas. I could just click that, and then I could just type in a multispectral imagery. Did I copy that? Yes, multispectral Landsat. I hit enter, and then this is it. So I just added it, and that is this particular one. So that is gone. So let's go to the next section. Study area. To create a localized defined study area analysis, focus on Athens, Greece. This is sprawling urban, blah 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 blah. So it said from the living atlas, add this. So let me just show you again. Instead of going to add data very quickly, you can just come back to the portal. This is the ArcGIS living atlas button here. Then I could just control V that, hit enter, and then I have the I think is this particular one, this first one. So we added that one to our study area, and that particular one, let me turn these ones off, is this particular one. You can see how wide it is. Okay, let me just turn on a base map so that you see the background to this. You can see that, right? You can see that. Okay, so I decided to just turn off the base map and the hill shade and have it here. Now the next thing we did was the layer is added. Turn off these, right click, zoom to layer. To right click and zoom to layer, you just like doing like so. Where is it? This, just right click, and then it says zoom to layer. Okay, so we right click on it and we click on zoom to layer. Where is zoom to layer? Yes, this. So that's how that one is done. Open the attribute table, select this row 1. To select it, hold down the shift key to 56. So that one, just like this, right click, attribute table. Okay, so we have opened the attribute table. So it says just click on the first one, scroll down to row 56, and then hold down the shift button. This is tricky. Shift button, let me hold the shift button. I've clicked on row 57. Now let me hold the control key and just select that row 57, and then they gave some other. They said hold down the shift key, right? Then they now said we should hold down the control key and unselect these rows like 18, 21, 26. So to do that, we just hold down this, and then we scroll up, and then hold down the control key. We say we should unselect 26, 18, go down to 26, unselect, and do that. When you complete that, what will happen is that only your study area points will be selected, right? features, sorry, not points. And then the next thing, zoom to a layer again. We did that. Then open geoprocessing pane in the copy feature, so we did that. Go to analysis tab. You go to analysis tab, and then okay, so we click on the analysis tab, and then we click on this, and then just here, just type in the copy features. No, copy features. Yes. So now with this, we could just copy the selected features to a new layer, right? Let's see how it goes. Set for the output, type in this. So for the output, just type in this. The input feature will be our days, and then the outputs, we now just type in that. Now look at it, this. So just to like do this, but note that I have already done that. So then I now clicked on run, so that is done, and we had this. So let me just go back to the map tab and clear selection, unselect this, close the attribute table, and that was how we got what they call it, our study area, which is this. Let's zoom to it, which is this. So let's check out the next section. The next section, we are through it here. So configure layer properties. So here is where we go. So the first input for our this HRI is land surface temperature. To derive land surface temperature, you must configure the layer to ensure that the appropriate properties are set. So we have this. You derive land surface temperature from multispectral Landsat imagery layer that you added to your project. The multispectral Landsat imagery layer contains decades of information for many visualization types. Select the correct visualization for land surface temperature. You must configure the processing template, the mosaic operator, and the definition query in the layer properties. In this step, you will configure these layer properties to select the land surface temperature data from the multispectral Landsat imagery layer. So turn on this multispectral Landsat imagery layer. The multispectral Landsat layer contains imagery of thermal energy that is emitted from the Earth's surface in two distinct bands. By using processing templates in the layer properties, you can convert the thermal imagery of the land surface into images that approximate surface temperature in either degrees Celsius or degrees Fahrenheit. You select the processing template that identifies land surface temperature in degrees Celsius. So they said right click multispectral Landsat image and choose properties. So they said we should right click this. Okay, I've turned it on, and then right click and we'll go to properties. Okay, good. Now what else did they say we should? In the layer properties dialog, click the processing template tab. Okay, so it said we should click on the processing template. Let's look at it here. We have clicked on it, and then next is for the processing template, click the down arrow and choose band 10 surface temperature Celsius. Okay, so let's look for processing templates. This processing template band 10, where is it? Band 10 surface temperature in Celsius. This. Next up, they said you have selected the processing template that identifies land surface temperature in degrees Celsius. Layers that are made up of cells, such as imagery layers, may include overlapping cells. The mosaic operator allows you to define how these overlapping cells are resolved. In this case, you will set the mosaic operator to mean, which will provide the average land surface temperature for overlapping cells. So click the mosaic tab. So they say we should click on the mosaic tab. Let's see, where's mosaic tab here? Here. Okay, for the mosaic operator, click down the down arrow and choose mean. So let's go mosaic operator, down arrow, and then we say mean. Where is it? No, not there. Look at the mosaic operator here. It's already on first, so change it to mean. So imagery layers may also contain images that are not necessary for deriving land surface temperature. In this case, the multispectral Landsat imagery layer specifically contains clouds and cloud shadows, which will interfere with your analysis. Using a definition query to filter out these cloudy images will improve the overall quality of your analysis. You will create a definition query that filters out all images with more than 5% cloud cover. So click the definition query tab. So we're gonna do that quickly. Where is definition query? They said we should just click here and then say confirm yes. So we say new definition query, right? That's what they did. Look at it here. Remove, click new definition query. So we said write a query that reads cloud cover is less than or equals to 0.05. So we're going to come here. Where is cloud cover? Here you are. So the operator is less than or equal to, here we type 0.05. Click on apply and then apply. Okay, click on apply again, then we'll click OK. Okay, so now click on apply again and then we'll click on OK. It may take a moment for the query to be applied. You change the symbology of the multispectral to visualize results of the configured layer. So we're going to open the symbology pane for the multispectral Landsat layer. Then in the symbology we set the following parameters. Okay, so let's go. Alright, so let's to open the symbology we just click on this. Okay, just click on it like so. It has opened. So it says color scheme to Inferno. So to do that, just click on this color scheme and then click on show names. So let's scroll down to, you see Inferno, N-E-O, look at it here, Inferno. Alright, and then the stretch type to minimum, maximum, right? So let's look at it here. Stretch type is currently on none, so go to minimum, maximum, and then statistics to DRO, that's dynamic range adjustment, and look at it here, statistics to dynamic range adjustment, right? And then due to the global coverage of the layer and change that you made to the layer, it may take a couple of minutes for the symbology to render. Okay, you've symbolized, save your project, you've configured your the layer properties of your multispectral Landsat imagery layer to select and symbolize the first input variable for your HRI and land surface temperature, blah blah blah. So next step is define your study area for the land surface temperature input variables. Let's save our map, but this thing is still refreshing, so let's just give it some time. So alright, so we have it like so, and then let's see what are we doing. They said define the study area for the land surface temp input variable. Okay, to be used as an input variable, the extent of the land surface temperature layer must match the study area of the heat risk index. In your case, the multispectral Landsat imagery layer covers the entire globe, but you need it to cover only Athens. In this step, you will create from the multispectral Landsat imagery layer a new layer that focuses on your study area of Athens. They said open the multispectral Landsat attributes table. Okay, so we're gonna right click and again go to attribute table, and then it may take a couple of minutes for the attribute table to load. Okay, zoom to Athens postcode layer. So we're gonna zoom to this, but let's wait for the attribute table to load. Okay, so right click on Athens postcode and then zoom to layer, and here we are. Okay, and then what else they say? You will use the map extent of Athens postcode layer to set the study area for the multispectral Landsat imagery. So you say at the bottom of the attribute table, click the filter by extent button to show records only for current map extent in the attribute table. So now you see, you come here and look at it here. Now let's just close this a bit. Let me close this. Okay, you're seeing it filter by extent. So once I click on that, it updates to show only records that fall within the map extent, right? Okay, like so. Let me just ensure that okay, the map extend is that of this our postcode. Let me just right click again. Let me do that again. Zoom to layer. Good. So this is our map extend. Okay, and then we're gonna click on this again. Okay, so we have clicked on the filter by map extend button. So what X do you say? You have set the map extend and filter the data. Okay, that you have set the map extend and filter the data in the attribute table and are now ready to copy the multispectral Landsat imagery layer to create a new layer that is focused on attends. So open the copy raster data management tool. Alright, so you're gonna just do that. Okay, you just come to the analysis tab again, and then we'll click on this. This one is copy raster data management tool. First, you adjust the tool's environment to set the processing extent and thereby clip the raster output to the attends postcode boundary. So in the environment tab, click the this and then choose attend postcode. So we're going to just do that. Okay, so I'll click on the environment tab and then the extent of a layer here and then attends postcode. That's it. Then on the parameters, the input is a multispectral Landsat, right? And you will complete the following parameters. Then for input, choose this. You want to save it as blah blah blah. You create a folder. I've already done that. For output raster dataset, click browse. We are saving this as this. Since I've already done this, the name for the output this. Okay, so I could just click here, click on folders. Okay, I've created this TIFF folder and this. So let me see if we can override it, because we already have this name, so we can overwrite it. And is that all? Click OK, save the project, blah blah blah. So let's run it. Click on run. So after running, we have this. Look at it. Okay. So we can save our map. Let's save. Let's go back to sorry, here. Okay, close the attribute table, save your project. You have the multispectral imagery that focuses on your study area. That means I can turn off the multispectral Landsat. Okay, I don't need it anymore. I only need this one for my study area. That's all. You can see it. Alright, so let's continue. 5. Summarize temperature values in a table. The final step in deriving a land surface temperature input variable is to summarize all the temperature values in each area to determine the maximum or hottest average temperature value in degrees Celsius. So in this step, you use the zonal statistics as table tool to create a summary table of the comprehensive values in each postcode polygon for attends. Open zonal statistics as a table. So we're going to do that. Copy. Here, just click on this back arrow, then we'll paste it in. Hit enter. This, let me see, spatial analyst. So get this. Okay, already have this table. So for input raster or feature zone, we're going to use this particular one. Sorry. For input raster or feature zone, choose the Athens postcodes. Sorry. Athens postcodes. Good. Then for zone fields, confirm that unique identifier is selected. The input value raster is the raster layer that contains the values that you want to use. Average land surface temperature in degrees Celsius. In this case, you want to determine the hottest average temperature for each postcode, so you will set the statistics type to maximum. For input value raster, choose this. Okay, input value raster, this. For output, type in IDs postcodes. So output table. Output table. Yeah. Okay. And then for statistics type, choose maximum. Maximum. Said click on run. Let's run. Okay, after running, we have this table here. Sorry. So you can just open it and view the attribute table here. So we have it like so. Save your project, and next up we'll go to identify tree canopy coverage. That's step 7. Second input variable in your HRI is tree canopy coverage to be derived from a layer. The tree canopy data must be isolated and the amount of coverage for the area calculated. You add an ArcGIS Living Atlas layer that shows global land cover categorized as 11 different land cover classes, including tree cover. Use the tree cover class to isolate the cells in the raster layer classified as tree cover. This will be used to calculate tree canopy coverage. I think we'll continue this next time. So let's end this video. Watch out for part 2.